Um, 23 and 24 are those shortcut rules. If you have log base A, if you have log base A of a base A raised to the fifth power, if this base here and that base there are the same, this log base A and that base A just cancel each other out. And so all you're left with is the exponent. This guy right here. That's your answer. It's just a shortcut rule. Because remember, logarithms, you're asking yourself, this A right here, you'd be saying A to the what power would equal A to the fifth. Well, hello, 5. A to the fifth equals A to the fifth. And then the same thing works on the next one. They've got, let me erase this. You've got E raised to the natural log base E, that's invisible, of x to the 13th. Same thing. This base here matches the base on the natural logarithm, so they cancel each other out. And all you're going to be left with is this. And so that's my answer. My answer is x to the 13th, that whole thing. It's just a shortcut rule. All right, 25 says solve the exponential equation. It doesn't look like it's an exponent, but it is. This is really base 3 raised to the 10 minus 2x power. And then I'm going to change the 9 here. The 9, that is going to change to a 3 squared. So that now I have the exact same base. I have a 3 to the this equals a 3 to the that. So you're just going to let your this, you're going to drop your bases, see ya, and let your this, the 10 minus 2x, equal your that, which is the 2. And then, you know, you're in Algebra 1. Solve it. So I'm going to subtract 10 from both sides. That cancels. Run out of room, follow me. And then I'll have negative 2x is equal to 2 minus 10 is a negative 8. And then you're going to divide both sides by the negative 2 so that that cancels. And x equals a negative 8 divided by negative 2 is a positive 4. And if you checked it, if you put 4 right here, 2 times 4 is 8, 10 minus 8 is 2, and 3 squared is 9. So it checks. Voila. Okay, and then 26, solve the exponential equation. Okay. On this one, the base over here is 3.7. The base over here is 44. It's impossible to solve this exponentially. So pack your bags. We're going to log land. You are going to take the log of both sides. I'm going to take the log of the 3.7 to the x. And on the other side, I will take the log of the 44. Now, on the left, I can use that exponent rule. It's the power rule because you've got this, you've got the log of something raised to the x. That x can go out in front. So this is going to become x times the log of a 3.7. And so all I have to do to solve for x is divide both sides by the log of 3.7. And that is me and my calculator. So just be careful. You have to close that parenthesis after you type in the 44. And it says round to 3 decimal places. So that's going to be 2.89. And then I have a 2, 3. So the 2 stays a 2 because the next number is a 3. Okay, and then 27 says solve this logarithmic equation. It's a single log. So if it's just a single log, pack your bags. We're heading back home to exponent land. You are going to start with the base of 4. And then you're going to raise that to whatever the log is equal to, because logarithms are equal to exponents. And then that's going to equal the only thing you have left in this problem, which is this x right here. That's what's going to go there. So I'm going to have a 4 to the negative third equal to the x. And that's already solved for x. I'm going to put x on the left this time. So 4 to the negative third equals x is the same as x equals 4 to the negative third. And then that's a negative exponent. So I'm going to drop it to the bottom, making it positive. And then 1 over 4 times 4 times 4 is 64. That is a horrible 6. There you go. Do I have time? Let me see. No, I'm going to stop the video and start a new one.